Okay, so redeem myself. For what values of m is this a tangent to the parabola? So, using derivatives, we are going to have y prime is just equal to negative 2x. All right, so we want that. That is our m, okay? So we want to see, this is a parabola like this, and plus 5, so we're going to have something like this and something like this. So we basically want to see where they intersect, okay? So we have 4 minus x squared equals mx plus 5, because these are the two, this is the line and the parabola. But now we have x and x, x and m. So we can't have that. We need our m to be the negative 2x. So, getting it equal to 0, we're going to have negative, so negative 2x squared here plus 5. So adding over the 2x squared, we're going to have x squared plus 4 minus 5. So that's going to be negative 1 is 0. So we have x is plus or minus 1. And when we sub that back into m, we're going to have plus or minus 2. Okay? So this is obviously the negative 2x plus 5, and this is the positive 2x plus 5. Okay, so that's method A. Method B is where we just have the two equal to each other. Get it equal to 0. So x squared plus mx plus 1. Derivative is going to be b squared minus 4. A is 1, c is 1. And we want that to intersect once because it's tangent. So m is going to be plus or minus 2. But much better. 31. F at x is that. Find the equations of the tangent lines passing through the point. Okay, so so we have f prime is going to be 10x. Okay, so just getting a picture. Here's our parabola, and we know the point 110 is not on the graph, okay? It's just like, because you see 115 is on the graph. If we sub in f at 1, so here's 115, but we want 110 to be on the graph. So it's going to be a tangent like this, okay? Okay, so the only thing we can start with is the general form with including q. So we're going to have y minus 10 equals the m, and then x minus the x coordinate 1. So 10x squared minus 10x plus 10 is going to be the general equation of our tangent line going through the point 110. So if we set this equal, we can find out what the x is going to be for this tangent line to intersect the parabola. So we're going to have 5x squared minus 10x. When we subtract that 5x over equals 0. So if we factor out a 5x, x minus 2. So at x equals 0 and x equals 2, we are going to have that general parabola, the general tangent meeting that parabola. So if we find our equations here, so that's going to be 0, 10, and if we do 2, we've got 5, 20, 30. Okay, so then we need the derivative at 0, which is 0, and the derivative at 2, which is 20. So our two lines should be y minus 10 equals mx minus 0. So it's obviously, because the derivative is 0, it's a max or a min. So it's just going to go through the y coordinate. So y is 10. That is, and I'm going to take a screenshot of the picture so you see. So here we have y minus the y coordinate 30 equals m x minus the x coordinate 2. So y equals 20x minus 40 plus 30, so minus 10. Okay, so you see here in blue, that's our parabola. Red is the line y equals 10, and the black line is 20x minus 10. So these two tangents to our blue graph both go through this point, 110. So they go through that point, but they're tangent to the curve, at different points. Here, it's at 0, 10, and up here, wherever it is, what is the point? It's 230. It's like here, something like that. Okay, so tough. 32, find the equations of the two tangent lines to the parabola y equals 4 minus x squared, which pass through the point. Okay, so again here, we're going to have our parabola, 4 minus x squared. So this is 4. This is 2 and negative 2. And it needs to go through 0, 5. Okay? These two tangent lines. So it's going to be like this and like that. Okay? So we need to find where these intersect. So, first of all, derivative is negative 2x. That's the general formula for our gradient, our slope of these two lines. So if it goes to the point 0, 5, we're going to have y equals m. That's our general m. X plus c, which is 5. You could have done it in the y minus y1 equals m bracket x minus x1, but we've got the y-intercept and we've got the gradient. So y equals negative 2x squared plus 5. Now we set this equal to 4 minus x squared. So, and then it's going to be x squared, adding the negative 2x squared over. So, yep. And then subtracting the 5. So we have at x equals plus and minus 1. That's here. This is 1 and this is negative 1. Now we need to find the points on the curve. So f at 1 and f at negative 1. So yeah, they're both going to be 3. So this is 3. And then we have the gradients there. So the gradient at 1, using this one, is negative 2. The gradient at negative 1 is going to be positive 2. So for this one, we're going to have y minus 3 equals m x minus 1. That is actually this line here. Okay? And you can see if we distribute, it's negative 2x plus 2 plus 3, so plus 5, because that's our y-intercept. Now for this one, we're going to have y minus 3 equals mx plus 1. So this one in that form would be y equals 2x plus 2 plus 5. And that's this one, because it's increasing gradient. Okay. All right, these long ones. The following diagram shows part of the graph of the quadratic function with equation that. So we know immediately that y is going to be equal to x minus 1, x minus 5. So p is 1, q rather, is 5. Because those are the x-intercepts. Write down the equation of the axis of symmetry. So it's right there in the middle. And don't forget equation, always. 5 plus 1 over 2, so 3. So that is that. Find the equation of the function in this form. So if we do, you can do it multiple ways, but we're going to have y equals x minus the axis of symmetry squared plus, we just need to find the y that corresponds with the x equals 3. 3 minus 5, so that's 2 times negative 2, negative 4. So that goes here. That's the vertex right there, 3, negative 4. Now, derivative. So you can do this multiple ways as well. We're going to have 2, x minus 3 to the 1. Chain rules, just multiplying by 1. And then the negative 4 goes away. So 2x minus 6, if we want to write it like that. And then d, let t be the tangent of the curve at 0, 5. So we want that from the equation. All right, so we have y at 5. Nope. We don't have to do that because they give us the point. So y at 0 is what I should have said, but anyways, we need the derivative at 0, which is negative 6. So since we have the y-intercept and the gradient, we can just go straight into y equals mx plus c. All right, the function defined as that. The diagram shows part of it. Maximum is at 3, 2. So we know straight away y is going to be negative x minus 3 squared plus 2. So h is 3, k is 2. Now we distribute to write it in that form. So negative x squared minus 6x plus 9 plus 2. So negative x squared plus 6x minus 9 plus 2 is minus 7. Now c, the derivative is negative 2x plus 6. The point Q lies on the curve and has coordinates 4, 1. So that's that. A straight line L through Q is perpendicular to the tangent. So what? So straight line, this is L, is perpendicular to the tangent. So we need this. So we need the derivative at 4, which is negative 2. So the perpendicular is 1 over 2, positive. And we have y minus 1, because it's going through that point 4, 1, equals mx minus 4. And then that should be di. The line L intersects the curve again at R. Okay, so we need to set this equal to the function. So we're going to have negative x squared plus 6x minus 7 equals, I'm just going to distribute 1/2 x plus 2, no, sorry, minus 2 and then plus 1. So minus 1 here, okay? So getting it, okay, I'm just going to multiply by 2 first off. And then getting it equal to 0. And then factoring. And we know to is going to be one of them. So maybe 4 here and 3 here. 6 and 4, no, that's not right. This is 4 and 3. So 8. So negative, negative. Oh yeah. So this is the x of the coordinate point R, because 4 is, we've already used it. So it's going to be like there, 1.5. Oh no. Maybe my line is not greatly drawn. Anyway, so if we do the function at 3 over 2, we're going to have negative 3 over 2 squared plus 6 times 3 over 2 minus 7. So that is negative 9/4 plus 18 over 2, which is 9, but 4 is 36 over 4. And then minus 28 over 4. So we're going to have negative 37, negative 1/4. So the other coordinate point, is 3/2, negative 1/4. So like here, I drew that terribly then. So So 1.5. So like here, 4, 1. So what's happening is that this is the perpendicular, these 2 points. Something like that. And then we have the tangent there. This doesn't look good at all, does it? Yeah, it doesn't look great. So basically, it's just because this is different scale that it doesn't look perpendicular. Because the blue line goes to the point 4, 1 and has gradient negative 2, like we found down here. And then the red line goes to the point 4, 1 and has gradient 1/2. And the other point it intersects the curve is at 3/2, negative 1/4. So, yeah. Okay, so now we have the derivative. So we're going to have just x, negative x, plus 2. And then the derivative at 0 is just 2. And n is the normal to the curve at the point where the graph intersects the y-axis. So we have the point where the graph intersects the y-axis is when x is 0. So it's 0, 2.5. And so we're going to have, y minus 2.5 equals m. But the perpendicular m is negative 1/2. So negative 0.5 x minus the x-coordinate 0. So we're going to have negative 0.5 x plus 2.5. That's for B. Now G is that thing. That's the normal. Find the solutions. So one of those should be 0. Negative 0.5 x squared plus 2x plus 2.5. So we know it intersects at 0. So those cancel. 0.5x squared. And then minus 2.5x is 0. So getting everything to the left side. And then factoring out a 0.5x, we're just going to have x minus 5 is 0. So x is 0, that's the 1, or x is 5, and we need the coordinates. So if we sub back in 5, we're going to have negative 0.5 times 5 squared. No, why we need to do, I mean, we can do it into f, but g is easier, isn't it? So g at 5 is negative 0.5 times 5 plus 2.5, which ends up being 0. So here is our situation. We've got the parabola, we've got, this is the normal, and if we would have done the tangent at at the y-intercept, that would have looked something like this. So that's the tangent. We've got the normal. It intersects at 0, 5, and here 5, 0. Sorry, that's 2.5, isn't it? And this is 5, 0.